Hey everybody, it's Mr. N here, and we are going to do another optimization problem. This one is another fencing problem, and let's go ahead and read this. It says a rectangular area of 6,400 square feet is to be fenced off. Two opposite sides will use fencing that costs $2 per square foot, or per foot, sorry, and the remaining sides will use fencing that costing $4 per foot. Find the dimensions of the rectangle with the lowest cost. All right, so what we have here is we've got this rectangle, and we've got fencing that we need to use, and along one side it costs $2 per foot. So we'll just say that this is our X and there's our Y, and it doesn't matter really which one you decide on because it'll take care of itself in the problem in the end. So our perimeter around this is going to be 2x's plus 2y's. And our area, we know x times y, which will be 6,400 square feet. Well, what's our cost going to be? Our cost equation is going to be twice in one and 4 times in the other. So whatever I choose for x, suppose x is the side that costs $2 per foot, and y is the side that costs $4 per foot. Now again, you could say 4x and 2y. It doesn't matter. It'll all work out in the end on this problem. So we'll just go ahead and say that the cost is 2 per foot here, and I've got 2 per foot there. So basically we're going to base it on this perimeter, and I'm going to multiply this one by 2. Let's use another color here. So this one by 2, and I'm going to multiply this one by 4 because it costs $4. So my cost equation will be $2 times the x's I use plus $4 times the y's that I use. So my cost equation becomes 4x plus 8y. Well, I want to minimize this to find the lowest cost right there. So what I need to do is I need to take this equation, the area equation, and I need to go ahead and solve and eliminate a variable. Let's go ahead and eliminate the y, and we'll just keep everything in terms of x since we're used to working with x a lot. So we'll say that the cost becomes 4 times my x plus, now we're going to go ahead and solve this, and y ends up being 6,400 over x. So plus 8 times 6,400 over x. So we can call this my c of x. And we can clean this up a little bit, and this ends up being 51,200 over x. Alright, so now we want to minimize it, and we want to find the least dimensions. Let's first think of a domain. Now, a feasible domain on this would be I can choose x as small as 0, but I can't make it equal to 0 because then it would be pretty much all length, no width, no area. And I can go all the way up to choosing it to be the maximum here of 6,400, but I don't want to go that far. I just want to keep it under. So these will not be equal to it, and what that tells me is I don't have to worry about the endpoints of the domain on this one. So those won't play a role in this too much. Alright, so let's go ahead and continue on here. We want to take a derivative because we're minimizing this, and we end up with 4 plus, now remember, this is 51200 x to the negative 1. So this becomes negative 51200, so 51,200 x to the negative 2. Well, when we minimize, we want to find critical points that are equal to 0. And we solve it. So we're going to say 4 equals 51,200 over x squared. If you're not sure what I did here, I said 4 plus, this becomes negative 51200 over x squared. And then I brought it to the other side to make it positive. Cross multiply, and you end up with x squared being 51,200 divided by that 4, which will give you 12,800. Take the square root, and you get 113.8 1371. So that means that's the x value I choose. I could plug it back in here and find the y, and we end up with y equaling 56.5685. And what will the cost be? Well, if we plug that in, we end up with a cost. If we plug in the x into our cost equation right here, we end up with our cost at 113.1371. Our cost ends up being $905, and I believe that's 10 cents. Now, some of you may be asking, okay, why couldn't we just in the beginning taken our cost equation, graphed it, and found a minimum value? You absolutely can do that. That's not an issue here. What we're trying to do, though, is develop that problem using calculus with derivatives. So that's why we took the derivative. That's why we moved on and did it in this method. And again, if this appears on an AP test on the multiple choice, the non-calc, well, you're going to have to be able to do this without a calculator, and so that won't help. That graphing method won't help you. You need to do it this way, but of course don't make the numbers come out nice so that you'll be able to have a number here that you could take the square root of. So hopefully this helped, and good luck with your optimizations.